All right, this is the note on alkynes. It's going to be fairly short. Alkynes, really the only difference between alkenes and alkynes is the number of number of bonds. So it's alkynes now we have triple bonds between the carbons. The only other thing that happens as well is that alkynes we don't have to worry about cis-trans isomerism, because once you have the triple bond established, and that was explained again in the hybridization video that you saw in the first unit, what happens with alkynes then is that because you have only the one species attached to each carbon at the other end of the triple bonds, those are free to rotate, and so therefore because there is no other species there, you don't have to worry about cis or trans isomerism. All right, the naming again, same as the double bonds. You also start at the end closest to the triple bond, start numbering from there. The longest chain has to include the triple bond. In terms of their reactivity, they are also unsaturated hydrocarbons, which means that you could break the triple bond to create more bonds to the carbon. They usually have higher boiling points than alkenes or alkanes with similar numbers of atoms. And the suffix of an alkyne is the YNE. All right. All other naming aspects are similar to that of the alkenes. Okay. So if we have some examples here, propyne. So 3 carbons. We start numbering at the carbon that's closest to the triple bond. So the triple bond is closest to the one end. That's the end we start numbering from, 1, 2, 3. So there really is only one position, because if you put it in the other position to switch them, then it's like just flipping the entire molecule, so you still have the same molecule. Once we get to the butynes, now we can move this triple bond to different positions. So this is but1-ine, and this one here is but2-ine. So same idea. This is what the line structures look like. What gets a little bit confusing sometimes is that especially with the programs that draw the structures that I use sometimes for making worksheets and that sort of thing, they don't leave a gap. When you do it by hand, it's easier because you can leave a gap between this line segment and this line segment to indicate that yes, there is a carbon here. That's not always as easy to do. These programs have a tendency to make sure that you understand it's a linear structure throughout. Quite often when they're drawn by hand, you don't have a tendency, and I'll show you in class what I mean by that. All right, the other ones now that we get to after alkynes are the cyclic hydrocarbons. And with this, we just put the cyclo prefix in front of the root to indicate that it's a ring structure. Generally, these are for the alkanes that have been looped around. What you'll notice about cycloalkanes is that they have the same molecular formula as some of the alkenes. Okay, the just same general CN 2N, H2N plus, actually H2N. So CnH2n is the general molecular formula for the cycloalkanes, which is the same as the alkenes. All right, try some of these homework questions, bring questions to class. We'll talk about them there.